Okay. So guys, now that we are going to discuss the UDP header. Can you see at the back? Rajesh? Fine, right? Okay. So now, UDP header, so it doesn't have many things here. It just only has 4 or 5 things. Let me tell you. So here you can see the first is source port number. Okay. And the second you got the destination port number. And you got length. The length says the header length. Okay. And the checksum as well. Okay, so this is it. Say the source port number, destination port number, length, and checksum. So while the TCP header has so many things, you can see this one. The TCP header consists of source port, destination port, sequence, acknowledged, data offset, reserved, CWR. A lot of bits are there, right? So because of these bits, they obtain the congestion management. They are they know, I mean, they have the error recovery procedure. They keep track of all these things and all. But UDP does not do these things because UDP does not have those things. Okay. Now we'll talk about the network layer. Okay. So now talking about the network layer, 3 main functions are there for the network layer. Okay. 3 main functions, of which the first function is called the routing. Yes, the first function is called routing. Okay, so routing here, let me tell you what is routing. If you got 2 networks, suppose we got some computers here. Okay, 10.0.0.0 network. Of course, you have studied the basics of the IP address, right? So now 10.0.0.0 network, and this machine is given with the assignable IP 10.0.0.1. And this machine is given with an IP 10.0.0.2, 10.0.0.3, 10.0.0.4, right? And these machines can be interconnected to each other by using a switch, right? Yes or no? Okay. Now it is interconnected to each other by a switch. The same thing, suppose you got some computers here. Suppose it's in the next classroom. Okay, in the CCNP classroom, where you got another network which will be 20 dot network. Okay, now you got 2 networks. Now these network will be interconnected to each other by using a device called a router. Okay, now you have, say you will connect it to the router. Here also you will connect it to the router. And the process of sending the packets from one network, 10 dot network, to the 20 dot network, this process is called routing. Clear? Okay, so when you are sending certain packets from one network to another, it's called routing. And you have a big topic or big section itself, routing, one of the main sections. Okay, so the further things you will study it in the routing portion. Okay, now the second one. The second process is called fragmentation. That's called fragmentation. Now let me tell you, yesterday we have studied about the segmentation. So in segmentation is coming in the transport layer. It comes in the transport layer, while fragmentation, it comes in the network layer. Now segmentation is done, say, by considering the end devices, or by considering the source machine and the destination machine. Okay, but the fragmentation can be done, or it is done, based on the in-between devices also. So now let me take a diagram here. Suppose you got a computer. This computer is in network 10.0.0.0 network. Okay, now this computer is then connected to a router, maybe to a switch, then to a router, then again to another router, suppose, and again to another router, again to another router. It is connected to multiple routers. Then it is connected to computer. Okay, now so suppose this is another network, 20.0.0.0 network. Now I told you the fragmentation process, say, it can be considered with respect to the, say, in-between devices also. So suppose, let me take the in-between devices R1 and R2, where let me take this in-between device R1 and R2 here. So here let me draw it again. Suppose we got R1 and R2. Now suppose say this computer is sending multiple packets. He's sending multiple packets. Now what happens is that, say the router 1 is now receiving multiple packets, and suppose the packet number 300. Packet number 300. He has received packet number 300. Now the routers or the in-between devices has also got a capability, and suppose his capability is to send 500 bytes of data. He has a capability to send 500 bytes of data. Okay, yesterday I told you about the capability of the end devices. The capability of the end devices. Right. Yesterday I remember like taking a 4000 bytes data and splitting it into 1000 bytes each. That is based on the in-between devices capability. Sorry, not the in-between, the end device capability. They will be exchanging something called MSS, maximum segment size, and they will be exchanging those parameters and all. Okay, now so here the router, they have something called MTU. They have got something called MTU, maximum transmission unit, the maximum value they can transmit. Okay, so that is, suppose that is 500 bytes. He is able to transmit 500 bytes at a time. Okay, now he is receiving a packet number 300, having a size of suppose 1500 bytes. Suppose he is having a, say something, or MTU size, sorry, the packet size is 1500 bytes, whereas the MTU is only 500 bytes. In that case, say this router is not able, or he will not be able to send the packet, the 1500 byte packet, because he is not able to send it. The maximum value he can transmit is only 500. Okay, so what he will do is that this packet, the packet number 300, so this is the packet number 300. Okay, so the 300, the packet, so the packet number 300, say you will use a value to identify the packets. It is called identification. So the identification is 300. That means the packet number 300. Now the packet number 300 is then divided. So what is the size of this packet? 1500 bytes. Now the packet is then divided into 3 parts, or it will be fragmented. It will be fragmented. Getting it? Okay, so it will be fragmented here. So first will be having 500 bytes, the next will be having 500 bytes, and again the next will also be having 500 bytes. So we have divided it into three fragments. Okay, now the identification, what is the identification here? It is 300. That means it is the 300 the packet that I have, say, fragmented. Right, the identification remains the same. Okay, now you got something called fragment offset. Fragment offset, which will tell you, say, which fragment it is. So here it is fragment 1, fragment 2, and fragment 3. Okay, now the next value, you got some bit values which are X, D, and M value. X means evil bit. The value is a constant. Okay, now D means don't fragment. Don't fragment. So this is fragmented. If the don't fragment bit is set, it will not be fragmented. Okay, so here this X value is constant, then the D value is 0, and the next value is more fragments. More fragments. After this, after the first fragment, we again got some more fragments. So this will be 1 here. The same here, X 0 1. And this time it will be X 0 0, because you do not have any more fragments. Clear? Okay, simple. Say X is a constant value, then D is don't fragment. Okay, D, if it is set, it will not be fragmented. Okay, then M here means more fragment, whether any more fragments are present here or not. So at the destination side, or at the router R2, when he receives these fragments, he'll have to join it again, or that process is called defragmentation. He'll have to join all these small fragments again to a symbol or a single packet. So at that time he will be checking whether any more fragments are there, yes, he will wait. Then now that he has got this fragment also, then he will understand no more fragments are there, then he will say defragment it. Clear? So this is the process and it is called fragmentation. Got it? And it is done at the network layer. Okay. Now the next one, the third one you already know, layer 3 addressing scheme. Layer 3 addressing scheme. We have studied the basics of the IP address, right? So layer 3 address means the IP address. So say the network layer provides the IP address, right? So you know the IP addressing schemes. Okay, so these are the, say, basic functions of the network layer. Okay, main functions you can say. Now again in the PowerPoint I have given some more things which we will study it in the later section. In the routing section I'll teach you these things. Clear? What is routed protocol, what is routing protocol and all, I'll teach you later in the routing section. Okay, now here I've given some network layer protocols here: IPv4, IPv6, IPX, AppleTalk, CLNS. These are the network layer protocols. Clear? Okay. Now shall we move to the next layer? Yes or no? Yes. Okay. And yes, of course, before moving to the next layer, again we got an IP header to study. Okay, so suppose, where is it? Yes. I suppose you can read it, right? Everyone? Okay. Now, so here, now let me tell you about this IP header. So here, yesterday I've drawn you the figure, or I've shown you the figure. Okay, so the packet structure looks like this. You have a data and the application header, the presentation header, the session header, the transport header and the network header. So this packet structure, it consists of the network header, along with that you have the segment, right? So if at all you are using the IPv4 here, then they will have the IPv4 header. So this is the IPv4 header that we are studying now. Okay, so now the first thing, it tells you which version of IP it is. Which version, whether it is IPv4 or whether it is IPv6. Then the next one says the header length, the length of the header. Okay, so the header can be from 20 to 60 bytes in size. The header can be from 20 to 60 bytes in size. Now next one, you have something called priority and type of service. Okay, or you can say this is type of service field, TOS, or type of service, or nowadays it's called differentiated service, DSCP. Okay, so here a type of service field, let me tell you about it. So if at all, say in the previous topology I have told you, say suppose the router is receiving multiple packets. The router is receiving multiple packets. If the router is receiving multiple packets, then the router, suppose the router will be processing it, but say he will process the different packets differently. Suppose, say this is a very important packet, it is marked as important, very important, or as urgent. Then what happens is that the router will process it immediately. Okay, now this packet is not so important, then the router will be processing it, but maybe a little bit later. Okay, and this is very important. So as soon as he receives it, he will process it with the highest priority. So marking it as, say, important, or the markings are done in this field, which is called TOS, or type of service. Okay, and at the last of CCNA you have a theory portion regarding this. Okay, now total length. Total length says the length of the, say, header plus the length of data. So the H plus D, or the header length plus the data length, will give you the total length. Now identification, I told you the identification is to identify the packets. right? Say the packet number 300 or the packet number 400. So you can identify the packets. Now you got flags here. Flags. Yesterday we have studied the TCP flag, right? Say I told you about, say, SYN bit, FIN bit, then urgent bit, acknowledgement, push, like that I've told you. Okay, similarly here in the IP header you got 3 bits flag. So 3 bits, let me show it to you. These are the X, D and M. Okay, able bit, don't fragment bit and more fragment bit. Okay, yesterday did I show you that the segment, guys, say the Wireshark, by taking the Wireshark? Yes, right. So there I showed you, I suppose, the bit values, right? The TCP flag, the TCP flag I have shown you. So similarly here, say again, let me, if at all, we'll capture it. Okay, and here also we got, say this is the UDP, but still, say when you check the inside, you got the IP header. So here you can see the IP header consists of the version, which says it is version 4. Okay, and the header length, I told you the size of the header can be from 20 to 60 bytes. Now the next one I told, yes, this is the differentiated service field, or this is the type of service field, differentiated service or type of service. Now the total length, the size of the header plus the size of the packet. Then the identification, the packet number, so it is 62,208. And now the flags, you can see the flags here. See the reserved bit, this is the evil bit which is reserved, don't fragment and more fragment. Now you got fragment offset, it is not fragmented, so the fragment offset is nil now. Okay, so this is the fragment offset value. So let me show it to you. Where is it? The fragment offset value. Fragment offset. Okay, then you got an important thing called TTL, which I'll tell you a little bit later. Okay, now you got protocol field. Protocol field, which will tell you, say, which protocol it is, whether it is TCP or whether it is UDP or whether it is some other network layer protocols. If it is for TCP, then the number it is 6, and if it is for UDP, the number is 17. Okay, so let me just, okay, I'll show you to a little bit later. Okay, now that we'll go with this one. So then you have something called header checksum, which is a simple error checking mechanism. Then then you have something called source IP and destination IP. So if at all, suppose two machines are sending something, of course this machine, suppose this is the source and this is the destination, the source will have an IP address and the destination will also have an IP address. So this is sent by whom to whom, that is what being told in this one, source IP and the destination IP. Then you have some options field, and this is the IPv4 header. Okay, so now let me just take the Wireshark here and again show it to you. So we were discussing about this one. So fragment offset, it is not fragmented, so we do not have the fragment offset here. Now the TTL value, again I'll tell you later. Now I told you the protocol, so for it will show you whether it is TCP, UDP or some other network layer protocols. So here it is UDP, and for UDP the number is 17. Okay, now you got something called header checksum, and then you got source and the destination IPs. Okay, clear guys, getting it? Okay, now say later below you can see the TCP, sorry, the UDP headers, which we have discussed it. So if you want to check the UDP headers, you can see this. The source port number, the destination port number, the length, and say the checksum field. That's it. Okay, small header. Okay, now then I've left one thing called TTL, time to live, which I'll tell you now. TTL. So TTL, or time to live, is used to avoid the layer 3 loops. It is used to avoid the layer 3 loops. So let me tell you what is layer 3 loop. Suppose Okay, suppose you are sending something from this computer which is 10.0.0.1 to, suppose this computer is having the IP 20.0.0.1. If you are sending something, say whatever is sent, it is sent to the router 1, it can be sent to the router 2, and you have router 3. So the packet will be sent to router 1 and it can be sent to router 2, and the router 2, instead of sending it to the computer, it can send it to the router 3, and the router 3 can send it to router 1, and again router 1 to 2 to 3 to 4, 1 again. So it can go as a loop. It can go as a loop. So this process is called layer 3 loop, and layer 3 loop needs to be avoided, and it is avoided by using something called TTL field. Okay, so when the computer is sending something, he will set a value. For TTL, he will set a value. Suppose he is setting the value 256. If he is setting the value 256, and then when the router receives it and when we process it, okay, so when he forwards it, he will decrease one value. He will decrease one value. So the 256 has become 255. Then when router 2 receives it, he will also forward it. So this value will become, instead of 254, he will decrease it as 250. So 255, he will decrease it to become 254. Then again when he forwards it, it will become 253. Then again 252, 251, like that it keeps on decreasing till the value 1 is reached. When the value 1 is reached, the router will process it and he will decrement the value as 0. When it becomes 0, he will not forward. He will not forward it, thereby avoiding the layer 3 loop. Clear? So the time to live, it doesn't tell you the time here, but instead it will tell you the number of routers which can be passed. Clear, guys? Any doubts? Okay, so this is the time to live. I suppose this is okay. Okay. Now, so this is the network layer header or the IPv4 header. Now we'll move into the data link layer. Okay, layer 2 or data link layer. Now, let me tell you, yes, anyone? Okay. So now we'll talk about the network layer, the data link layer. Now first let me tell you, the data link layer is split into two parts. The data link layer is split into two parts or two sublayers. The first sublayer is called MAC sublayer, media access control, MAC sublayer. Now the second sublayer is called LLC sublayer or logical link sublayer or link logical sublayer. Okay, so it consists of two sublayers, MAC and LLC. Now, so the data link layer actually, it connects the physical things. It connects the physical things means if you have the NIC, this is the NIC. So the NIC is connected, or say whatever that they are interacting with the NIC, the data link layer is interacting with the NIC, right? So they are getting in touch with the physical layer as well as they are getting in touch with the upper layers. Upper layers in the sense, say not that these things, but the network layer, the transport, the session, like that. So these layers, or you can say like this, the data link layer acts between the physical implemented hardware, the physically implemented hardware, and they acts between the physically implemented hardware and the software kind of thing. Okay, so they got two portions, MAC sublayer which interacts with the physical hardwares or the physical layer, and the LLC which interacts with the network layer. Clear? Okay, so this is the data link layer, sublayers of the data link layer. Okay, now again let me tell you, okay, data link layer functions. The first function is called the framing and deframing. Say the framing means the encapsulating the packet structure with the data link layer header and the data link layer trailer. Okay, this process is called framing, and at the destination side this will be decapsulated, and that is called deframing. Clear? Okay, now the next is MAC address discovery, which is very important, and we'll talk about it at the last. Okay, now you got another process called switching. Switching means, suppose if you have multiple computers, if you have multiple computers, and these computers are connected to the layer 2 device now, or the switch. Okay, now if the first computer is sending something to the fourth computer, then it is the message or the frame is sent to the switch, and the switch will forward the frame from this interface to this interface. So forwarding the frame from one interface to another interface, it is called switching. Clear? And again, we got a major section in switching. We will study the switching in that section. Okay, now another thing you have already know this, layer 2 addressing scheme. Layer 2 addressing scheme, it means the MAC addressing. It means the MAC addressing. Okay, so you know about the MAC address, right? So how many bits is MAC address, guys?
128.
128. Not at all. MAC address, how many?
60 something. I'm not sure.
Nope. Not at all. Guys, these are very fundamentals. MAC address, how many bits is the MAC address? I taught you the MAC address, right? Yes or no?
Yes.
So at that time, what did I tell you? If you want to take a look at the notebook, you can take it. But yes.
32.
Nope, it's 48 bit. IPv4 address, it is 32 bit address, but the MAC address is 48 bit. Okay, so don't ever make mistakes in these things. These are very basic thing. Okay, if you go for the interview and if they ask how many bit is the MAC address, and if you tell 32 bit or 128 bit or something like 8 bit or all, at that very moment itself you will be made to go out, because that is very basic. Okay, so keep it in mind. Say this is the MAC address is 48 bit and IP address is 32 bit address. I mean IPv4 address is 32 bit address, and IPv6 address, it is 128 bit address. Clear? Don't get confused. Okay, now again, so MAC address consists of two parts. I told you about the two parts and all, right? And again, did I tell you the difference between the MAC address and the IP address? Yes or no? Yes. Okay, so MAC address, it's coming in the layer 2, while IP address is coming in the layer 3. Now MAC address cannot be changed. It is a 48 bit address, and IP, suppose if it's IPv4, then that is 32 bit address. Now MAC address is physical address and it cannot be changed. Okay, this is logical address and can be changed by the network administrator himself. Clear? Now MAC address, one more thing let me tell you, MAC address can be considered as a driving license. It can be considered like that. Okay, now IP address, it is something like a passport, can be considered like a passport. Okay, that means, say passport, let me tell you. So, or let me start with the driving license. If you are in your network, means if you are in India, I suppose everyone are Indian, right? So now we are Indians, and suppose if we are in India, and if at all suppose police catch us, and if at all they ask us to produce the, say, identity, then you can produce the identity, the driving license, you can produce it within the network. Say the MAC address will be valid, or there will be MAC address. Now going outside, suppose you are going to US, and say if suppose the police catch you and they ask you to show the identity, then what will you do? There the driving license is not valid. There the passport, only the passport is valid. So meaning that, say once you communicate from one network to another network, the IP address is there. Getting it? So the IP address is relevant, not the MAC address. Clear, guys? Okay. Now, so these are the difference between the IP and the MAC. Now, say you got one more thing, the next function, which is called error checking mechanism. Let me tell you what it is. Suppose, say this is the frame. You got a packet and you got a data link layer header and a data link layer trailer. So this header, say what happens is that, say whenever they calculate the header values are added along with the the header values are added along with the data value. Okay, header plus data is added and is stored as a complex value in the trailer. and that's called CRC code, cyclic redundancy check code. So now what happens is that at the destination side, say they will do the same thing here. When they receive the frame, say suppose when they receive the frame, they will calculate the header value plus data value, and they will check whether it is equivalent to the trailer or not. If it is equivalent, they'll accept it. If it is, say, not equal, then they will discard it because of some errors. It has become different and they will discard it. Get it, guys? And that is why it's called error checking mechanism. Clear? Okay. So this is the error checking mechanism. Okay. Now coming back to the last one, which is MAC address discovery, which is also very important. Okay. So now you can expect 100% or 200% question from this one itself. Okay, so now let me just tell you, let me just draw this one. Suppose you got some computers here, machine 1, suppose this is machine 2, machine 3 and machine 4. Okay, now say these machines are interconnected by a switch in between. You got a switch and it's interconnected. Okay, now let me tell you. So here, yes, suppose this machine has an IP address 10.0.0.1. This is having an IP 10.0.0.2. This is having the IP 10.0.0.3. This is having the IP 10.0.0.4. Okay. Now let me tell you, say suppose the machine 1 has got a MAC address 0001 A2B3 C4D5. Now this machine has got a MAC address 0002 A1B1 C2B2. Now this has got a MAC address 00B4 15AC 24BD, something like that. Now again here 001B 1234 1234. These are the MAC addresses of the devices. Now suppose if computer 1 wants to communicate to computer 4, or say computer 1 wants to communicate to computer 2. Okay, now let me tell you. So here, if first machine wants to communicate to the second machine, what happens is that, say this is the message, and this will be encapsulated with the application layer header, the presentation layer header, then the session layer header, then the transport layer header, then the network layer header. So here in the network layer header you got two values, source IP and the destination IP. So what is the source IP, guys? 10.0.0.10.0.0.1. And what the destination IP? 10.0.0.2. Okay. Now let me tell you. So the source IP, it can fill it because it's its own. The first machine can fill it because it's its own IP. Now the destination IP, how will they come to know about the destination IP? Any idea? Nope. Let me tell you. They'll come to know about the destination IP by using DNS. By using DNS. Did I tell you about the DNS yesterday? Yes, right. So if at all you are working in an organization, say your organization will have a server called DNS server, and this DNS server will have all the IP addresses and the respective names, the domain names. So these computers will also have the domain names. Suppose it is something like this: computer 1, suppose you are working in Cisco, then computer 1 at cisco.com, then computer 2 at cisco.com, computer 3 at cisco.com, computer 4 at cisco.com. So these are the domain names. The domain name and the IP address will be there in the DNS server. Okay, so they will say what happens is that when they reach the network layer, then if they do not know the destination IP, say they will send, or this computer, the computer 1 will send a DNS request. The computer 1 will send the DNS request. So it will be sent to the DNS server. Say this message consists of these things. Say, hey DNS server, what is the IP address of computer 1 at cisco.com or computer 2 at cisco.com? Then they will say the DNS will search their, say their the records, their things and all, and they will send back a DNS reply. And the DNS reply will be having the respective, say, domain name along with the IP address. Clear, guys? So this is how they will come to know with the destination IP. Now they know the destination IP. Then say they will fill the network layer header, and then they will move to the data link layer header, and say data, or they'll move to the layer 2 where they need to fill the data link layer header. In the data link layer header, they have the source MAC address and the destination MAC address. So let me ask you, say, what is the source MAC and what is the destination MAC? Yes, the source MAC will be the MAC address of the source machine, which is the first machine. So the MAC address will be this one. Suppose I am just writing it as MAC 1, and suppose this is MAC 2. So the source MAC is MAC 1 and the destination MAC is MAC 2. So but the source MAC, they are able to fill it because it's their own MAC address. But what about the destination MAC? If the destination MAC is not known, or if it is unknown, then they will use a process called MAC address discovery. They'll use a process called MAC address discovery to discover the destination machine's MAC address. Clear, guys? Okay, so now let me tell you, to discover the destination machine's MAC address, they will use the MAC address discovery procedure. And what they are going to do is that the first machine, they will send a message called ARP request. They'll utilize a protocol called ARP, address resolution protocol. They'll utilize something called address resolution protocol. So they'll send something called ARP request. Okay, so let me tell you about ARP. ARP is the protocol which is used to find out the MAC address by using the IP address. We know the IP address, which is 10.0.0.2. With this IP address, we need to find out the MAC address of the device. So they will send the ARP request, and the ARP request will be like this. So the ARP request will be having an ARP header, ARP header, and they have, in addition to the ARP header, they have a layer 2 header, the data link layer header. So in the ARP header, they have got the target, they have got some fields called target IP and target MAC. Target IP and target MAC. It is targeted to find out the MAC address of 10.0.0.2. So the target IP will be 10.0.0.2. Getting it, guys? Now the target MAC we do not know. We are actually trying to find out the MAC address. So this target MAC will be nil. Okay. Now in the layer 2 header, you got the source MAC and you got the destination MAC. So the source MAC will be this MAC address, the machine's one MAC address, or it is MAC 1. MAC 1. And the destination MAC, it's a specific MAC address which is a universal broadcast MAC address, which is FFFF.FFFF.FFFF. It's a specific MAC address known as universal broadcast MAC address. Clear? So this is the ARP request. This is the ARP request. Now it is received by the switch. Now the switch will do, say the switch will check this one. This frame will be checked by the switch, and the switch, what he will do is that it's a broadcast. It's a broadcast message. So it will be sent, this message ARP request will be sent to all the machines excluding the source machine, or excluding the source interface. It will be sent to all the interfaces, and that process called flooding. So switch will flood it to everyone. Now machine 2 will receive it, machine 3 will receive it, and machine 4, everyone will receive it. Okay, now everyone will check, so everyone will receive this frame or this via the layer 1 and will pass it to layer 2, which is the data link layer. So if you receive a letter, what will you do, guys? You will check whether the to address is your name or not, right? Whether the letter has come for you or not. If the letter has come for you, then you will tear it and you will read it. Getting it? So the same thing will be checked by the computers. So they will check the destination MAC address, the to address, whether say it has come for them or not. Okay, so when they check it, it's the universal broadcast. That means the broadcast means it is meant for everyone in that network. So it is meant for the machine 2, it is meant for the machine 3, it is meant for the machine 4 also. So all the machine will accept it in the layer 2 and will pass it to the LLC sublayer of layer 2. Will pass it to LLC sublayer of layer 2. And now the LLC layer or the LLC sublayer, the logical link sublayer. So the LLC sublayer will check the target IP with its own IP. Will check the target IP with its own IP. So whether it is really sent for him or not. Okay. Now, sorry guys. Now the target IP is 10.0.0.2. So the machine 3 will compare its MAC address with the target IP. Sorry, its IP address with the target IP. Whether both are same. Yes or no? No. So that means it is discarded. Everyone getting it? Okay, so this time it is discarded. Now here the machine 4 also checks the same thing. So whether the target IP matches his IP or not, it doesn't match, so it is discarded. Now machine 2 will check it and he will come to know that yes, it matches. That means this ARP request is sent for him, and so he will send back an ARP reply. He will send back an ARP reply, and the ARP reply will have this IP address and the MAC address 10.0.0.2. okay, and the respective MAC address will be there. Clear? So this is the ARP reply, and the ARP reply will be sent to the machine 1, and the machine 1 will come to know about this MAC address. So now the machine know that 10.0.0.2 IP is having so and so MAC address, and then he can start sending the frames. Clear? So what we have done, or this machine 1 has done, machine 1 has sent the ARP request and received back an ARP reply. So then he can start sending the frames to that machine. Now this information, the IP to the MAC information, will be stored in a cache table called ARP cache table. It is stored in a temporary storage table called ARP cache table. So whenever the machine 1 wants to send something to 10.0.0.2, this MAC address is there, or this MAC address, say suppose for 10.0.0.2 the MAC address is 0002 A1B1 C2B2. It is stored there, so that they don't have to send the ARP request every time. They can just check it and they can just fill it. Clear? So this process is called MAC address discovery, which is a function of data link layer. Clear? So this is the data link layer. Any doubts? Anything? Okay. So that's the data link layer. And now coming to the physical layer, which you have studied it. Say the cabling things and all we have studied. Okay. So the physical layer consists of cabling things, and it consists of hub and all. So hub works in the physical layer, which we have already covered. Okay, so this is the OSI reference model. Okay, now let me tell you. So here, so this is the OSI. OSI consists of how many layers? 7 layers. So the layer 7 is application layer, presentation layer, session, transport, network, data link, and physical layer. Now This is the TCP/IP model. This is the TCP/IP model, or it's called TCP/IP protocol suite or TCP/IP protocol stack. So in TCP/IP protocol suite, so you can see, so the application presentation session, all these three upper layers are grouped together and it is called application layer. Then the transport layer is called host to host layer, and the network layer is called internet layer, and the data link layer and physical layer have been grouped together and it is called network access layer. So this is the TCP/IP model. Any doubts? Okay. So and again, whatever the protocols you have it in the application presentation and session, they come in the application layer, and the transport layer protocol exists in the host to host layer, and the network layer protocols exist in the internet layer, and the data link layer protocols and the physical layer protocols will be there in the network access layer. Okay. So this is the difference.
One query here, like in the OSI, we have been, designating also as layer one, layer two. So in this, for the application process, what we'll call it, layer four, is it?
Layer 4 again, that I have not thought about it. Okay, so there I suppose, let me check and get back, but still
Okay,
I suppose that it will not be called like that. Okay, it's actually a 4 layer, 5 layer architecture. Okay, it can be. Let me check and get back to you then. Okay.
okay.
Yes. Anything else from you guys? So this is the OSI model. Okay, now shall we take a small break then and get back to the next topic? Okay, so we'll get back at 9 o'clock. Okay, then we'll go on with another topic called subnetting. Okay, I suppose everyone is aware of the IP address, the basics of IP address, right? Yes or no?
Yes.
Okay. So if at all you are not aware, you can instead of taking a break, you can revise the portion, because if you don't know those things, then you will not be able to understand subnetting. Okay. Yes. So guys, then shall we start? Okay. So yes, let me take paint. Okay. So guys, let me give you a question then to find out the network address. Sorry, to find out the class. Then the subnet mask, the network address, broadcast address, and assignable IP address. Okay, so now giving you some questions. Say 192.100.186.144. Okay, then the second one, yes,
186.
yes, 186, 186. Okay, now 151 dot 152 dot 100 dot 200, then 11 dot 12 dot 13 dot 14. Yes, please write down, guys. Now guys, now what about the first one here? See the first question, so we'll discuss the first one here. Which class it belongs to, guys? Class C. Yes, very good. And what is the subnet mask here? 255.255.255.0. Okay. Now what is the network address? 192.100.186.0. Guys, I need everyone's answer. Okay. Now, or else again, or else, yes. Now, what is the broadcast address? 192.100.186.255. And the assignable IP range?
192.100.186.1
Okay. 192.100.186.1 to 192. Say 100.186.254. So this is the assignable IP range. Now what about this question, the second question, guys?
Class B.
Class B. Okay.
255.255.0.0.
Okay, 255.255.0.0 is the subnet mask. And the network address?
151.152.0.0.
Now, what is the broadcast address?
151.152.255.255.
Okay. And the assignable IP address?
151.152.0.1. 151.255.255.
Okay. So it will be in between the network address and the broadcast address. Okay. Everyone okay? Okay. Then guys, again the next one. So yes, just give me a moment. Let me delete this also. Okay guys. So which class it is?
A.
A. And the subnet mask?
255.0.0.0.
Yes, 255.0.0.0. Now the next one.
11.0.
Yes, network address is 11.0.0.0. And the broadcast address?
11.255.255.255.
Okay, 11.255.255.255. And the assignable IP? 11.255.255.254. So this is the assignable IP. Clear guys? Okay. Now let me tell you, we are gonna discuss it briefly. Okay, because we got a process and all. I'm not gonna discuss it now. Maybe we'll discuss it briefly. That's it. Now we'll discuss a topic called subnetting. Okay, and in subnetting, let me tell you what it is. Okay, so here you're given with a big network here. Suppose 11 dot, or say here, let me take this case here, this machine's case. Okay, this network, it is class C address, and you know that, say, it consists of, say, the assignable IP .1 to .254. That means how many IP addresses can be accommodated, guys? 254 IP addresses can be accommodated, right? Or you got this value either by calculating it from .1 to 254, or you might have calculated like in this manner, right? How many host portions are there? 8 bits are host portions, so 2 raised to 8 values will be there. Yes, so 2 raised to 8 minus 2, you will have to decrease the network address and the broadcast address from that list. Then you will have, say, 2 raised to 8 is 256 minus 2, 254 IP addresses. Clear? Okay. So this is how you got 254. Now, suppose, let me tell you with a useful example here. Okay. Now, here we got a big hall. Suppose we have got a very big hall. Okay. If you got a hall here, now how many people? 1, 2, 3, 4, 5, 6, 7, 8, including me, 9 people. Okay. So 9 people, or let us consider, say 9, 10, 11, 12, 13. So the online people, including everyone, we have 13 people. Okay. Now, so here we got a very big hall, and in this hall, suppose 254 people can sit. In this hall, how many people can sit? 254 people can sit. If 254 people can sit, and we got 13 people here. Okay. Now I am sitting here, and you guys are sitting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people, including me, 13. So the problem is that, say, if you guys sit randomly, then the entire hall is utilized. The entire hall is utilized. What is the problem? So nobody else can take the class here. Okay, nobody else can take the class. In between, you got many seats here. In between these two people itself, we got many seats. So lot of seats will be vacant, but still nobody else will able to take the class. So to arrange it properly, so what happens is that the space is wasted. The space is wasted. Many more people can sit, but we are sitting lavishly, but so that say nobody else will be able to take the class, right? So what we will do is that, suppose if we have a very big hall where 254 people can sit, so I'll be here, suppose, and you guys will be sitting in an order 1 2 3 4 5 6 7 8 9 10 11 12. Okay, now we have occupied this area, so that means I can take a class here, and maybe the CCNP faculty, he can take a class here, right? And any other faculty can take class here. So what we have done, we have arranged ourselves accordingly in such a way that no seats are getting wasted. Clear, guys? Or what we did is we have created smaller classrooms. We have created smaller classrooms, so that the classrooms or the seats will not get wasted. Clear? The same concept is with the subnetting also. Let me tell you. Suppose, let me just replace the seats with the IP addresses. Okay, so this IP, it is 192.100.186.1, right? So here you got a big network where you can include 254 machines. You can include how many machines? 254 machines. So now if you have 12 machines, and or 13 machines suppose, and I'm giving an IP like this for .1 here, say 10 here, .20, .30, .50, .70, say 90, .100, say .150, .175, .200 and .250. The problem is that I say randomly I have given IP addresses to a computer. Okay, so the rest of the IPs are getting wasted. Why do we need to waste the IPs? Right. So to avoid the IP wastage, we will be doing subnetting. So subnetting means, say here, when we do subnetting, okay, so here you got how many IPs? 254 IPs here. Suppose 256 IPs, including the network address and the broadcast address. Okay, so what I'm going to do is, if we have, say, 256 IPs, I will divide it into smaller subnets. Okay, suppose the first subnet, it consists of .0 to suppose say in case 32. Okay, .02 or .0 to .31 suppose. Okay, so if we have computers, I can give the IPs like this: .1, .2, .3, .4, .5, .6, .7, .8, .9, like that up to .31 you can give. Clear? And the rest of the IPs starting from .32 to .254 can be saved and can be used for another purpose. Get it, guys? So what we have done is we have arranged it in some specific manner, and or we have cut it into smaller pieces, and we have, say, created some smaller subnet. Or it's called subnetwork. Subnet or subnetwork. Clear, guys? Okay, so this is what we are gonna do. Okay, so now here let me take this IP itself. Let me take this IP 192.100.186.144. Okay, so this is the IP. Okay, now say I'll be the process and all I'll tell you later. Okay, now let me just tell you some small things here. Okay, let me first tell you about two types of IP addresses. You can say two types of IP address. First is called classful IP. Suppose classful IP, let me give you some example. Say 192. This address itself. Okay, 192.100. 192.186.144. 192.100.186.144. Now, what is the subnet mask, guys? Again, one more time. Sorry?
Dividing the network.
Yeah, of course, it's the term. And what is the subnet mask here for this IP? 255.255.255.0. Okay. So, of course, you know the subnet mask means you will differentiate the network portion and the host portion. So, how many network portions are here? Three networks portions are there, of course. And how many network bits are there? 24 network bits are there, right? So 24 network bits. So from now on I'll be writing it like this. The IP address will be written like this, /24. Clear, guys? So if I write like this, then that means here you got 24 bits for the network portion. And this value, say after the slash and after we write this one, this value is called prefix length. What is it called? Prefix length. Or that is called CIDR value. It's also called CIDR value. Prefix length or CIDR value.
So if it's a class B address, then
Yes.
it will be /12.
No,
16.
it will be /60. Okay, so let me just take another one. Say here, I suppose I've given you some IP like this: 150.151. and 100.181. Okay, so now which is this class? Class B. It's class B. If it is class B, how many network portions will be there? 16 network bits will be there. So we'll be now writing /16. Okay, now what about this one? Say 18.19.20.21 /8. Clear, guys? We have written this prefix length based on the default subnet mask, right? Say you got a value called subnet mask, which is the default subnet mask. So the default subnet mask for class C is 255.255.255.0, and the default subnet mask for class B is 255.255.0.0, and the default subnet mask for class A is 255.0.0.0. Clear? So here the classful IP says it obeys the default subnet mask. Clear? Now let me tell you, or let me now take another one. Classless address. Classless address. Now if I take an IP like this, 18.19.20.21, okay, it is /8 here, right? But instead I'm writing /24. /24. So now if I ask you which class it belongs to,
C.
so yes, somebody has told it belongs to class C because of this prefix length. Any other answers?
Class A.
Class A, because you have noticed it starts with 18 and so it is class A, but it is neither class A nor class C. It is classless address. It is classless address. It doesn't obey the default subnet mask. So when you look onto this, say 18.19.20.21, that means it ought to be class A with respect to the first octet value, and with respect to this one, say this prefix length, it ought to be class C. Okay, so it doesn't obey the default subnet mask, and so it is called classless address. Anyone who want to repeat that again?
So why classless address are happening?
Classless address, I'll tell you. Okay, so here again you got how many IP addresses here? Say assignable IP will be 1 crore something, like 1 crore 67 lakh 77,214 IP addresses will be there. Okay, if you go with the classful. Okay, now we are going with the classless means, say we are customizing on our own, or we are subnetting it on our own. Okay, so when you subnet, that subnet mask will change, the number of machines will change, and the parameters will change. Okay, so it cannot be considered as classful address. Okay, now again say here, now let me tell you. So next one, say 200.182.163.144/8. What about this address? Which class does it belong to, guys? Class?
Classless.
It's classless. Okay, again let me tell you, it starts with 200. If it is 200, then it ought to be class C, but if it is class C, then the subnet mask should be 255.255.255.0. that means 24 bits needed to be reserved for network, but we haven't reserved 24 bits for the network, we just have only 8 bits for the network. So it doesn't obey the default subnet mask, and so it is classless address. Clear? Okay,
Where is this used? Classless.
we'll study that. It is used everywhere. Okay, now that it is used everywhere, we'll study. Okay,
So that means this is not hypothetical. This is like real.
sorry.
So classless addresses are not hypothetical. We use it in our environment.
Yes,
Okay.
of course we use it. Okay, even let me tell you. Okay, say let me show it to you. Say let me take the command prompt. IP config. Okay, you can see it here. So the IP address that I am having it is 172.16.3.112. And what is the subnet mask here? 255.255.255.0. Okay, so that means here you can say if it is 172, it ought to be class B. If it is class B, then 16 bits, only 16 bits need to be reserved for the network. But here how many bits are for the network? 24 bits are for the network.
24
So the IP address here is 172.16.3.112/24, which is also another class, it's classless address.
Mm-hmm. Okay.
Okay, so it is used, of course it is used. Okay, now let me come to the point here. So you know the difference between the classful IP and the classless IP. Okay, now we'll do the subnetting here. Okay, or guys, let me ask you one thing. Do you want to study it today, or do you want to study it on Monday? Do you want to study it on Monday fresh?
We can study
Today?
We can study today, yeah,
Okay,
if we have time.
but guys, it may take some time. I suppose that you may not, or you do not have, or you are not that busy, I suppose. Yes, everyone? Okay,
That's
now,
fine, yeah.
okay, I'll tell you one question. Now let me tell you, suppose I'm taking an IP. Okay, so now let me take the previous IP itself, this IP itself. Again, let me take this IP. Okay, here you got how many assignable IPs here? 254 assignable IPs. Okay, now suppose while doing subnetting, you will be given with a requirement. So first type of subnetting that I'm going to teach you is subnetting based on, you can say, number of machines. Subnetting based on number of machines. Okay, so now let me tell you about this subnetting based on number of machines. Here you are given with a subnet, or you are given with a network. Okay, suppose let me take a simple network, 192.168.10. network, or 10.100. Of course, this is class C. The network address is 192.168.10.0, and the broadcast address is 192.168.10.255, and the assignable IP is 192.168.10.1 to 192.168.10.254. This is the network address, the broadcast address, and the assignable IP address of the big network that you are given with. Okay, now so here you are given with an IP and you are given with a requirement. You are asked to subnet it for 60 machines per subnet. You are asked to subnet it for 60 machines per subnet. That means you have a big network here, and this network needs to be divided into smaller subnets. and each subnet should have how many machines? 60 machines. 60 machine, 60 machine, 60 machine, 60 machine, 60 machine, like that. Clear? Okay, now to do this one, let me tell you. So again, let me write down the network address here. So the network address here, just give me a minute. Okay, the network address here is 192.168.10.0. okay, that means, say by default it is having 24 bits as the network by default. Okay, now how many bits are reserved for the host? 8 bits are reserved for the host. Okay, or suppose you are given with /24 itself. Okay, here you are also given with the IP /24. So here this is the question. Okay, so you are already given with /24. So that means 24 bits are reserved for the network. I suppose no doubt still it, right? Okay. Now let me expand the host bits here. What I'm going to do, I'm going to expand the host bits. So let me just first tell you the agenda here. Okay, so what I'm going to do here is that, so you got a very big network and I told you we'll be dividing it into smaller subnet. Now say for the big network, it had a network address, it had a broadcast address, and it had an assignable IP address. The same thing applies for each subnet. When you divide it into smaller pieces, each subnet has got their own subnetwork address, the network address, their own broadcast address, and they have assignable IP address also. Clear? Again, the second subnet also has their own subnetwork address, then the broadcast address, then the assignable IP address. Okay, again the third one also has the subnet address, the broadcast address, and the assignable IP address. Clear? Everyone? Now what I'm gonna do is I'll be writing a table, and I'll be writing a table where the first thing, it is the subnet address or the subnetwork address and their own broadcast address, then the assignable IP address range. This is what we are gonna do. Clear? Okay, so now let me do it now. So I'm gonna expand the host portion. So when I expand the host portion here, okay, when I expand the host portion, I'm gonna expand it, say up to here it is the network portion, I'm expanding it 000000000. I expanded the host portion, 8 bits I've expanded it. Okay, now you are given with a requirement. Okay, the requirement is 60 machines per subnet. Okay, so what I'm gonna do is that I'm gonna write the values 1, 2, 4, 8, 16, 32, 64, 128. Of course, I suppose you know how to write it. Okay, and why to write it also? Yes or no? Because we are using the binary, we do not have 1's place, 10's place, 100's place, 1000's place like that. Instead, we have 1's place, 2's place, 4's place, 8's place, 16's place, etc. Okay, now what we are going to do is, say your requirement is 60 machine, and you're going to check where the 60 machine is coming, where your requirement is coming. When you check this one, your requirement 60 will come in between the 64 and 32. Your requirement will come between the 64 and 32. So what you're going to do is, you're going to draw a line here. Get it, guys? So when you draw a line, that means you have, say previously you had the network portion up to here till the black line. Now you have extended the network bits. You have extended 2 more bits to the network. What you did? You extended 2 more bits to the network. It's a little difficult to understand. Trust me, after say writing it down, you will understand it later. Okay, when we discuss it, you will understand it later. So you have added 2 more bits to the network. Okay, and whatever it is being added here, this 2 bit, it is called subnet portion. It is called subnet portion. Okay, so we have just added 2 more bits to the network. Just give me a moment. Okay, so now how many bits you have it here? 2 bits you have it in the subnet portion. How many bits you have it in the subnet portion? 2 bits. If you have 2 bits, if you have n bits, guys, how many values you have? How many combinations you can write? Didn't I tell you an equation? Yes, 2 raised to n values you can write. So that means if you have 2 bits, how many values you can write? 2 raised to 2 values you can write. That means 4 values you can write. That means, let me tell you, so here how many portions you have expanded to the network portion, or how many subnet portion is there? 2 portions, 2 bits are there. That means 2 raised to 2 subnets will be there. That means I'll divide this into 4 subnets. Everyone getting, or do you want me to explain one more time? One more? Okay, again let me tell you, here I've expanded the host bits, expanded the network bits. I've expanded 2 more bits. Okay, or I can tell you like that, I have 2 bits in the subnet portion. I have how many bits? 2 bits in the subnet portion. If I have 2 bits in the subnet portion, then 2 raised to 2 values will be there total. That means 4 values will be there for the subnet. Getting it? That means I have a big network here. I am dividing the whole network into how many pieces? 4 pieces. Clear? So first piece, second piece, third piece, and the fourth piece, or I am dividing the entire network into 4 subnets. Clear? Okay, we are gonna now find out each subnet's network address, broadcast address, and assignable IP address. Shall we? Okay, yes or no? Everyone?
Yes.
There, Lakshit?
Yes, sir.
Okay, now, so what we are gonna do is, so I'm gonna write down a table here. Okay, let me write down a table. Or let me just delete it. Okay, so the table here, it consists of subnet address, the broadcast address, and assignable IP address. Assignable IP address. Okay, now we are going to write each. Now let me tell you, to write the subnet address, this is the network portion. This is the network portion. Okay, now let me tell you, the network portion, we will be writing it exactly like that. We will not change it. Okay, so this value remains the same. 192.168.10. Portion remains the same. So the first subnet, it will be like this. So now how many bits you got it? 2 bits you got it. Now you can write the combination like this: 00, 01, 10, 11. I suppose everyone know how to write the combination. Am I right? Okay. Now to write the subnet portion, or to write the network address, you know, all the host portion will be made zeros. All the host portion will be made zeros. While teaching you the basic IP address also, I told you to find out the network address, you will make all the host portions as 0. To find out the broadcast address, all the host portions will be made 1. Now we will find it out. So now what we are going to do is, let me just tell you, to find out the first subnet, this portion remains the same. So 192.168.10. Okay, now this is the first subnet that you are going to find out. That means this is the first 00. We are going to take the first value, which is 00. Now to find out the subnet address, all the host portions will be made zeros. So how many host portions are there? 6 host bits are there. All the 6 bits will be made 0. 0, 0, 0, 0, 0, 0. Then the 4th octet value, what is the value here? 0. All the octets or all the bits have become 0. So the value will become 0 here. Clear? Paka? Now to find out the broadcast address, again we will keep on writing this value. This value is same. The network portion is same. So it is 192.168. This value also remains the same because this is for the first subnet we are writing. 00 will remain the same. Then we will make all the host bits as 1. Okay, so this here we will make all the host bits as 1 here. 1 1 1 1 1 1. Okay, now this value will be, so 192.168.10 dot is same. Okay, now what is this value? To find out this value, you will add all these values. Wherever you have 1, you will add all these values. So 1 and this one 1 1 1 1. The values are 1 2 4 8 16 32.
63.
Okay, when you add all these values, you're gonna get the value called 63. It might be confusing for you, but trust me, later I'll tell you an easy method. Okay, now just go with this method. Okay, now you found out the broadcast address as 192.168.10.63. Now what is the assignable IP address, guys? You got the subnet address and the broadcast address. So in between the subnet and the broadcast, you will have the assignable IP address, which is say from .1 to .62. Okay, so you will write the assignable IP like this: 192.168.10.1 to 192.168.10.62. Clear? Now the next one. Okay, now the next one here, again 192. So this is common. 192.168.10 dot is common for everyone. So the next one is 192.168.10 dot. Now yes, the next one. This we are going to find out the second subnet address. So we are taking the second value here. We are taking this second value. Okay, now to find out the network address, we will make all the host bits as 0. So we will make all the host bits as 0 here. And what is the value for this one now?
64.
64. Getting it, everyone? How did you get 64 here?
Because the one portion has the 64.
Do we need to add anything?
No.
Sure. Okay, so here you got 1 here, say, and the value corresponds to that one is 64. We don't need to add anything because here we do not have any other ones here, only a single one, and the value corresponds to 64. So this value will become 64 here. Got it? Now to find out the broadcast address, again to find out the broadcast address, let me tell you, this value will remain the same. 192.168.10 dot will remain the same. So we'll write it down: 192.168.10 dot. Yes. Now what we are going to do is we'll make all the host bits as 1. So when you make all the host bits as 1, 1 1 1 1 1 1. Now you already have 0 and 1 here. Along with that, you are adding all these ones. So you already have this 64. Along with the 64, you are adding these values. When you add these values, say that 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. When you add it, what is the value, guys?
127.
127. Clear? Now if you are not able to add, no worries. Okay, say go home today, you can work on this one. Okay, go home, try to add it in your mind, don't use calculator. If you keep on adding with the calculator, then you will not understand anything. If you say add it in your mind, you will have some logic. Okay, now what is the assignable IP here? Yes, 192.168.10.65, which is the say next one of the subnet address. Okay, to 192.168.10.126, which will be in between the network address and the broadcast address. Getting it, everyone? Okay, now the next one, the next subnet. So the next subnet says, say again, this value 192.168.10 dot value will be constant or will be same. So 192.168.10 dot. Now you got the third value, which is 10. Okay, and you will make all the host bits as 0. Okay, now what will be the value this time?
128.
128. How did you get the 128?
Because of one.
Yes, you got this value over here, and the value corresponds to 128. So the value is 128. Okay, now to write down the broadcast address, again 192.168.10 dot. Now yes, 191. How did you get the 191? You will make all the host bits as 1 here. Okay, so this value here will be considered, that means the value you have 128 here, along with 128 you will add all these values 32, 16, 8, 4, 2 and 1. Then when you add everything, you will get 191. Okay, then again the say this assignable IP, which is 192.168.10.129 to 192.168.10.190. Okay, and coming to the last one, say again when you calculate the same using the same method. Do you want me to explain this one or just write the answers?
Right.
There, Ritik, do you want me to write 000 and explain? Sure, everyone getting it? Okay, here also. Okay, so what, say when you calculate it, say this network address will become 192.168.10.192, and here it will become 192.168.10.255, and here the assignable IP will be 192.168.10.193 to 192.168.10.254. Clear? Okay, now let me tell you, so this is how you subnet. And now finally let me just tell you, I have subnetted. So what I have done is I have got a very big network, and the very big network, say it started, where is it guys, it started from .0 to .255. that is the very big network. Okay, so the very big network, it started from .0 to .255, ended at 255, and you can see this. So now when you take a look at here, the subnet .0 to .63. Okay, so the first subnet, so I told you we have cut it into 4 pieces or 4 subnet. So 1, 2, 3 and 4. So the first subnet, it started from .0 and ended where? Ended at .63. So it ended at .63. And the next subnet, you can see it started at .64. It started at .64 here, and it ended at .127. .127. Now the third one, it started at .128 and it ended at .191. And at last you can see the last one started at 192 and ended at 255. So it started at .192 and ended at .255. So you can see it is going continuously, and in between we are just cutting it. That's it. Clear guys? Okay, so this is going continuously. So 0 to 63 first one, 64 to 127 second one, and 128 to 191 third one, and 192 to 255 the fourth one. Clear? Now one more thing. So here 60 machines can be accommodated in a subnet. So here when you check each subnet, say the assignable IPs, how many IPs are there? 62 IPs are there. So the first one, the subnet, consists of the assignable IPs .1 to .62. That means 62 machines can be accommodated here in the first subnet. When you check here, the second subnet, how many IPs can be accommodated here, guys? 62. So when you minus 126 minus 65, that will give you 61, including the 65th IP, you're gonna get 62 IPs. Getting it? Again, the third one also supports 62 machines. The fourth one also supports 62 machines. So, of course, if you want to include 60 machines, say the 62, you can see each subnet can contain 62. 2 IPs are extra. Let it be there. Okay, so some extra IPs can be there and let it be there. No issues. Maybe we can assign it for some other guys in the future. Okay, so now say we can see 60 machines per subnet. That means say here we have satisfied our condition. We have 62 machines per subnet. So this is how you do the subnetting. Clear? Everyone fine? Okay, so if you want you can note it down. Okay, if you want you can note it down.
Question.
Yes, please.
So in the beginning, right, we have divided the host 8 bits into 2.
Host 8 bits into 2. I mean, yes, I have just drawn the line like this. Yes, that one, yes.
So why 2?
Why 2 means, say, to require or to satisfy my condition that, say, let me tell you, if I draw here, my condition will not get satisfied. Okay, because, say here, let me again tell you, how many host bits are there here? Here 6 host bits are there. Okay, I have drawn the line there because 6 host bits are there, and that means how many IP addresses will be there? 2 raised to 6 IP addresses will be there. 2 raised to 6 minus 2. So that means 2 raised to 6 means 64 minus 2, 62. Only if I draw there, I'll have that the sufficient quantity. If I draw here means I'll not have sufficient quantity. And again, if I draw here means the again IPs will be say wasted. Lot of IPs will be there. Got it? Okay. Yes. So if you want you can note it down. Okay. Or yes. And you can do this question. Okay, go home. It's a must that you do this question, and I'll give you 2 homeworks also. Try to do it. Okay, try to do it. Okay, yes guys, make it faster, make it faster. Okay,
Bharat, I have a question.
yes please.
Subnetting can be done in equal sizes, like we have divided into 4 subnets, this network, right?
Yes.
So it can be always divided in equal subnets. In for example, if I want to have only 60 machines in the first subnet and rest 61 to 254 machines in the another subnet, is it possible to do subnet in that case? It's not gonna be like it's suitable or it's not suitable. What is it like? I'm not sure about that.
Okay, I'll tell you. There are 2 parts. The first thing is that we will divide it. Okay, we will divide it not from we have a specific value called a block size. Okay, block size. So we can divide it. So your question was something like this. So the first subnet, whether you can divide it, of course, with 62, that is fine. And you got some other subnets also here. Of course, you can have 30 machines here. Okay, of course, in the next subnet you can have 10 machines here. Okay, you can subnet it according to your wish. We'll come to that as the last portion of the subnetting.
Okay.
Yes.
Right. So it's possible to do informally.
It's
Okay.
possible, but again, let me tell you, when you do for 30 machines or when you do it for 10 machines, you are not really say allocating or giving it for 10 machines alone. Say you got a specific block size and 16 will be the say block size there. That means 16 machines or 14 machines can be assigned. Okay, you have a specific block size, so of course that can be done, but with a definite block size. Okay, which you will understand
Okay.
later. Okay.
Okay.
Yes.
Okay.
Yes, guys, please carry on. Make it faster, faster, faster. Or if you want, you can take a snap. You can take a photo also. Anyway, that I'll be uploading the video as well. Okay. If anyone can take a snap and put it in the group, that is also good. Okay. Yeah, the group is created. You can ping me to join the group. Okay. I'll be like sending you the group link. Okay. Yes. Yes.
No. You will send the group link.
Yes. Okay.
On which platform, sorry?
WhatsApp only. You want to write it? Okay, then let me give you a question.
So you can go to WhatsApp web and take a screenshot and paste it in the
Of course.
possible.
Yeah, of course. Somebody has already pasted, I suppose. Thank you. Whoever it's pasted. Thanks for that. Yes. Okay. He has taken the photo and he has pasted it in the group also. Okay. So now guys, yes. Now let me give you a homework. 2 homeworks. Okay. Try to do it. Try your maximum to do it. And if at all you face any difficulties, ping me in WhatsApp also. No issues. Okay. So the next question is, say 200 dot 184 dot 186 dot 154 slash 24. Okay, and the requirement is 30 machines per subnet. 30 machines per subnet. And one more, 208 dot 209 dot 210 dot 211. 10 machines per subnet. As we are having 2 days holidays, I'm giving 2 questions.
So subnet value for that.
Yeah, slash 24 itself. Okay. It's not the subnet value, that we call it as a prefix length or CIDR value. Okay. Yes. Okay. Yes. So then, shall we wind up the class for then? Okay. So we'll get back on Monday, and by that time you should be familiar with this one. Okay. If you have any doubts, please ping me in WhatsApp. So I may be delayed. If at all you ping me, you can ping me in 12 a.m. or 1 a.m. or whatever time. But the problem is that if I sleep, then I'll not reply. Okay. So thank you guys. We'll see you on Monday then.
So, we drawn a line between for 2, right?
Yes, I've drawn a line between 64 and 32.
32.
Yes.
If we need 54 machines per subnet.
Sorry? If we?
54 machines.
For 64 machines.
54.
64, there's a small thing here. So if you got 64 here, I'll be drawing between 128 and 64 here. Okay, I'll tell you why. Because if you have 64 machines, okay, 64 is your requirement. So here, how many bits you have? 6 bits you have, and 2 raised to 6 IP addresses will be there. 2 raised to 6 IP means, say, 64 IP, exactly 64 IP. But again, when you decrement 2, the network address and the broadcast address will be decremented or will be, say, excluded. That means you will only have 62 IPs. Okay, so now if at all your requirement is 64 IPs, then you will draw between 128 and 64. Getting it? Where you will have 7 bits for the host and 2 raised to 7 values will be there, 128 values will be there, minus 2 will give you 126 IPs. Clear? Okay. Yes. So thank you. Yes. And online guys, just hold on a minute. Even if I've told thank you and all, just hold on a minute because I need to take. Yes. And again, let me now. Thank you. Okay. Now